Alright, in this video I want to talk just briefly about limits and how we're going to use them in pre-calculus. Specifically, when you see the notation, what you should be thinking. Okay? So, when you see this notation on the left, you should be thinking, what are the y values approaching? The y values of the function approaching as x approaches positive infinity. Alright? As you move to the right on the x-axis, what are the y values approaching? The second thing is the same idea, but what are the y values approaching as x approaches negative infinity? In other words, as you look far down the x-axis to the left, what are the y values doing? So let's look at an example real quick. So we have this function f of x equals 1 over x, and we're asked what is the limit as x approaches infinity of the function, and that means what are the y values approaching as we look to the right on the x-axis. Alright, well, you can see in this function that the graph goes down and it gets really close to the x-axis. The further you go to the right, if you were to look at a table of values, for instance, the further you looked as x gets large in a positive direction, you would see it approach 0, or those y values get closer to 0. If we ask, so we would write this, we'd write that this is equal to 0. And if we ask this question, what are the y values doing as x approaches negative infinity? Then we would be looking to the left. Okay, so as you move to the left on the x-axis, what are the y values approaching? What are they getting close to? They're getting closer to 0. You can see that here. Okay, so this leads us right into a definition for horizontal asymptotes. The definition of a horizontal asymptote is a value that is approached by the function as x approaches positive or negative infinity. So it could be either one. Alright, now so here you would have horizontal asymptote at y equals 0, and we usually draw those in as dotted lines. Okay, and there's a common misconception about horizontal asymptotes. We know that vertical asymptotes the graph can't cross. Those are discontinuities in the graph. A graph can't cross a vertical asymptote. However, the definition of horizontal asymptote says nothing about crossing it. It just says that the function has to get close to a particular value, closer and closer to a particular value. We call that approaching a particular value as x approaches positive or negative infinity. So let's look at an example of that. So here in this example, you can see that clearly the graph crosses the x-axis. But if you look at positive infinity, so if you look down the x-axis here, you see that the y values are clearly getting closer and closer to the x-axis. They're clearly approaching 0. And as you look to the left, you can see that the y values are clearly approaching 0 as well. Okay, so here we would say that there's a horizontal asymptote at y equals 0. All right, even though it crosses the line, there's a lot going on near the origin here. But we don't care about that. When we're looking at horizontal asymptotes or we're looking at end behavior, that's really what these questions are asking. What is happening at the ends of the graph? We're only concerned about what's happening at the ends of the graph. So we're not concerned about crossing the x-axis here or whatever the asymptote is. We're concerned about what are the y values approaching as x approaches positive infinity or negative infinity. One last note, you can have two horizontal asymptotes in a graph. You could have the limit to the right approach a value like 2. You could have the limit to the left approach a value like -4. Okay? So it does not always have to be the same value, although lots of times it is.